Good evening and welcome to Master Talker online class. If today is your first day of watching our video, please consider subscribing. Okay, today we are going to talk about circular motion. Okay, now circular motion simply means how do I put it? Okay, they say an object moving with a uniform speed along a circular path is said to undergo uniform circular motion. Now, example of a circular motion is your fan. Your fan is fixed about a point and then the blade is moving in a circular path. Okay, that is circular motion. So that is that. Now they say that the magnitude of the speed of the object is constant, but its direction changes in a uniform manner. Thus, the velocity of the object is changing. This change in velocity brought about by the change in the direction constitutes acceleration. This acceleration is directed towards the center of the circular path. Please don't forget, in circular motion like this, okay, the velocity is acting on the tangent path. This is where the velocity is acting, but the acceleration is acting towards the center. The acceleration is coming to the center, but the velocity is acting on the tangent. Okay, so they say that the acceleration is directed toward the center of the circular path, and it is called centripetal acceleration. From the word center, it is called centripetal acceleration. Okay, so they say the magnitude of the centripetal acceleration is given by A, which is equal to V squared over R. Very important formula to note. V squared over R. Okay, that is the formula for what? Centripetal acceleration, where my V is what? The uniform velocity, uniform speed, or uniform velocity, uniform speed, and my R is what? The radius of the circular path. Okay, radius of the circular path. Okay, and my A is what? Centripetal acceleration. Centripetal acceleration. Now, don't forget that they can ask you, there is centripetal the acceleration of a body in a circular path acts in what direction? It acts towards the center, and it is called what? Centripetal acceleration. Okay, they say for a body to accelerate, there must be a force acting. Okay, for a body to accelerate, there must be a force causing the acceleration, and it's true. It's only if when something is being pushed, that is what will make the body to move or change direction. Okay, then I said, sorry, for a body to accelerate, there must be a force causing the acceleration. Thus, this acceleration is directed towards the center of the circular path. Is caused by a force which acts towards the center of the circular path inward. Okay, this force is called the centripetal force. Okay, centripetal force. Therefore, centripetal force is that inward force required to keep an object with a constant speed in a circular path. Please don't forget, centripetal force is that inward force that is required to keep an object moving with a constant speed in a circular path. And then we know that my force is equal to what? MA. Okay, so my centripetal force, let me call it FT, is equal to what? M times centripetal acceleration. Let me call this centripetal acceleration. So which means my centripetal force is equal to what? mv squared over what? Over R. Very important formula. Okay, so now the next one is what? Centrifugal force. Centrifugal force is a force that cancels the centripetal force, or the force that is required to act in opposite direction with the centripetal force, so that it can balance that object to remain in constant acceleration. Let me say the way they said it here. They said, since centripetal force keeps the object moving in a circular path, there must be an equal and opposite force which balances the object from falling inward. Okay, this is, as the centripetal force is acting inward, centrifugal force will be acting outward. That is what to make it balance. Okay, and that is what, to be in line with the Newton's third law of motion, which said to every action there is equal and opposite reaction. So thus, centrifugal force is an equal but opposite force which balances the centripetal force to keep the object moving in a circular path. So if I have a circular path like this, okay, and maybe this is the fixed point, and I have something in this way, don't forget that the velocity acts on the tangent. This is where the velocity acts, but the acceleration acts to the center, inward, and that is where the centripetal force acts. So the centrifugal force will not act outside, outward. This is centrifugal force. Okay, so that is how it is. Okay, so now from this place, let's talk about linear acceleration. I'm sorry, angular speed or angular acceleration. So angular speed and velocity. Okay, angular speed and velocity. Now if I have a circle like this, that makes an arc. This is theta, the angle of the arc. Now from A to B, the distance from A to B is called the length of the arc. We are aware of it. This is the radius, okay? And don't forget that the velocity acts on what? On the tangent. This is where the velocity acts, okay? I have this. So where my theta, don't forget that my theta is called the angular displacement. The theta is called angular displacement. Okay, my r is called the radius. Okay, my s, the distance, is called what? The length of the arc. Okay, and my v is called, the v there is called the linear velocity. Okay, now let's now talk about angular velocity. I know that linear velocity means displacement over time, which means angular velocity w will now be what? Angular displacement over what? Over time. Now, but we know how to get our angular displacement. Now let's get our distance. Let's get our distance, and we know that what? Distance is set as the length of the arc. So formula for length of an arc in mathematics is what? Theta over 360 times 2 pi r. Don't forget. And pi in mathematics, they told us, is 180. So 2 times 180 is 360. 360 will cancel 360. So I'm left with s is equal to what? Theta r. Okay? Now my theta will now be what? S over what? R. Can I put it here? Yes. So therefore, my angular velocity is equal to what? S over r, which is my theta, divided by my time. Okay? So what do I have now? Theta is equal to what? S over r times 1 over t. Okay? Now my w will now be what? This can change position. They can change position. This is set as what? S over what? RT. They can change position to have S over t times 1 over r. S over t times 1 over r. Okay? So this will now give me, but I know that S over t, distance over time, means velocity. So therefore, my angular velocity is what? My linear velocity divided by what? Divided by what? R. Okay? Let me write it very well. So I'm having that what? My W is now what? Distance over time is velocity. Velocity what? Times my radius. Okay? So my linear velocity, divided by my radius over R. Okay? So therefore, my linear velocity is equal to what? Angular velocity times what? The radius. Very important formula. Very important formula. Okay, so we have 3 important formulas now. 1, 2, and what? And 3. Okay, in fact we have 4. The 4 of them is that you should know that that distance is equal to what? Theta r. Very important formula. Distance is equal to theta r. But if you cannot remember this thing, know that distance means the length of an arc. Then use formula for length of an arc to get this one. Okay? For this number 2, if you cannot remember it, just remember this one. That centripetal acceleration is what? Velocity over v squared over r. Then force means ma. Then attach my m to get my centripetal force. That one is very simple to remember. Okay? So now let's talk about angular acceleration. we have gotten the relationship between angular velocity and the linear velocity. So now let's talk about angular acceleration. Angular acceleration. Now we know that normally acceleration A is equal to what? Change in velocity over what? Over time, which can be what? The final velocity, let me call it v2, minus initial velocity v1 all over what? Time. The same thing should happen to angular acceleration. Angular velocity is A, but linear acceleration is A, but angular acceleration will represent it with alpha. Alpha should be what? Change in angular. Since we are talking about angular, everywhere will not be angular. Change in angular velocity over what? Over time, which can be what? Angular velocity 2 minus angular velocity 1 all over what? Time. But don't forget what is our angular velocity. Angular velocity is what? Linear velocity over r. So let us now put it. So angular acceleration will now be what? v2 over r minus v1 over r, everybody divided by what? By t. Okay, so if I now have LCM, here, I'm going to have what? They have just one r. I'm now having v2 minus v1 all over what? T. Okay, this r can come down here to have that your what am I saying? Okay, this thing can come out here to have that what? That I'm having that angular acceleration is equal to what? V squared, v2 minus v1 all over what? RT. Okay, but I know something now. Angular acceleration is equal to what? v2 minus v1 all over time times 1 over r. Is it not? Okay, or let me just do it like that. Watch. From here, this thing means that angular acceleration is equal to what? v2 minus v1 all over r divided by t. Is it not? Which divide can change to times. So to have times 1 over t. So they can change position so that I have that angular acceleration is equal to what? v2 minus v1 all over time times 1 over r. But I know that v2 minus v1 over time means linear acceleration. So therefore, let me complete it here. So therefore, my angular acceleration is equal to what? Linear acceleration over what? Over r. Because this one means linear acceleration. Linear acceleration, watch it. Linear acceleration times 1 over r. So angular acceleration is what? Linear acceleration over what? R. So therefore, linear acceleration is what? Angular acceleration times what? Times r. Another important formula. Angular acceleration times r. Okay? Now, angular acceleration over r. Okay, so from here there is something that is important here. From here I know that acceleration is simply change in velocity. It's simply velocity over time. We know that velocity over time. And don't forget that velocity means the same thing as this. So therefore, acceleration is the same thing as saying WR over T. WR over T. Okay? So let me now WR over T. I want to get the relationship. So let me get what my R will be. WR over T. That is my velocity. WR over T. Okay? I want to replace this man with omega. So how do we get the relationship between them? Okay? I'm having that velocity is equal to this over T. Okay? How do we bring in this here? Okay, and we know that we know that alpha is equal to what? Angular velocity over what? Over time. Is it not? Angular velocity over time. So I'm having that A there is equal to what? Instead of putting this one, let me put angular velocity over time, then R. Okay, angular velocity over time, then R. Then angular velocity over time. Angular velocity over time is something as saying is it? Sorry. Okay. From this place, I don't want to get confused. Okay. I'm having that over R. So I'm having that my A is equal to what? Angular acceleration times R. Okay. This is the important formula we need to have. Okay. From here, I'm going to have that okay. Am I okay? So, but I know that my A is equal to what? Velocity, angular velocity. Okay, velocity over time. Velocity over time. Have I gotten A anywhere? Okay, velocity over time. My A is velocity over time, which is certain as saying WR over time. Okay, WR over time, which is equal to what? W in bracket of R over T. Okay, R over T. And what is my R over T? My R over T is equal to omega. I hope you know. R over T is equal to omega. So I'm going to have, what do I have now? So therefore, W bracket R over T means omega times R. R over T is velocity. Is it not? R over T is velocity. Okay, R over T is velocity. So which A is equal to what? WV. A is equal to WV. Yes, A is equal to WV. So linear acceleration means linear angular velocity times linear velocity. Okay, so but V is equal to WR. So I'm having that A is equal to what? W squared R. This is another formula that I'm looking for. This is another formula that I'm looking for. So that is that. So let us write out all our formula, then we start solving calculation. Oh, we still have time. So let's write out all our formula, then we'll start solving calculation. Let's know how to remember all our formula. Okay, the first formula you need to remember is what? From the acceleration, centripetal acceleration is what? V squared over R. The first formula you need to remember. Okay, which will now give you that centripetal force, okay, is equal to what? MA, which will now give you what? MV squared over what? Over R. The second formula you need to remember. Now let's move to linear acceleration, linear speed, angular speed and velocity. Angular speed and velocity. Just know that V is equal to what? WR. V is equal to WR. Okay, that's the relationship between the two of them. Okay, and alpha. In fact, the only thing is just attach R to it. Just attach R to it. Watch me, watch me. Look at what I mean by attach R to it. The relationship between the angular and the linear is just the ratio. It's just the radius. So for linear velocity, V should be what? Angular velocity times R. Which means linear acceleration should be what? Angular acceleration times R. You see, these things are very, very simple to remember. Okay, so their difference is simply the relationship between them is just to be adding your R. So another thing you now need to remember is the relationship between linear acceleration and angular velocity. Linear acceleration and angular velocity is simply angular velocity squared R. That's all. So these are the only formulas you need to remember. Then case file closed. Another last formula you need to remember is that distance means the length of tangent, and length of tangent is what? Theta over 360 times what? 2 pi r. And then you know that 2 pi can cancel 360. So speed now is equal to what? That's all. In fact, watch me. In summary of this formula, watch me now. In summary of this formula, just know this one. Acceleration is equal to what? V squared over r. Okay. Therefore, the centripetal force should be what? A v squared over r. This one is very simple to remember, is it not? Now, anything angular and the normal one, just put arrow to it. Anything angular and the normal one, just put arrow to it. Now, normal speed is equal to what? Angular speed. Angular speed is theta. Then put arrow to it. That's all. That's all. We are done with speed. Now come to velocity. Linear normal velocity is equal to what? Angular velocity. Just put arrow to it. That's all. Then the next one is what? Acceleration. Normal acceleration is equal to what? Angular acceleration. Just put arrow to it. That's all. That's all. You see, the formulas are very, very simple to remember. Now let's start answering our question. But before we start answering our question, don't forget that there's a relationship between A and W. So A is equal to, just say, W squared R. Okay, that's all. That's all. So these are the only formulas you need for circular motion, and then you are good to go. You can solve everything. And don't forget that what? Velocity normally is measured in what? Meter per second. While the angular velocity is measured in what? Radian per second. Okay? Normal acceleration is measured in what? Meter per second square. While the what? Angular acceleration is rad per second square. Sorry, rad per second square. And then you are okay. You are okay. While the angular displacement is measured in radian. Okay. While the normal speed is measured in what? In meters. So these are the only thing you need to know for angular, what is it called? Circular motion, and then you are good. So let's start answering questions. The first question said, a stone is wedged round a circular path, okay, of radius 15 cm, full stop. They say if the stone makes 30 oscillation in 10 seconds. Okay, calculate the angular speed. Calculate the angular speed of the stone. Then they now gave us that pi is equal to 3.142. Okay, solution. Now there is something you need to know. You need to know that one complete oscillation, they gave us 30 oscillations. So one oscillation is equal to what? A complete circle, which is what? 360. Okay, 360 degrees. Now therefore 20 oscillation, okay, is equal to what? Because they don't give us theta, so it's equal to the theta we are looking for. Okay, so that is how to find your theta. Okay, so I'm going to do cross multiply now. If I do cross multiply, theta times 1 theta is equal to this times this, 20 times 360. So I'm having that what? Theta is equal to what? If I want to put it in pi, don't forget that 360 means 2 times pi. 360 is that as in 2 times 180. And which is what? 2 times pi. So which is what? 20 times 2 pi. So I'm having that theta is equal to what? 40 pi. I've gotten my theta. Okay, why am I using pi? Because I want my answer to be in radian. So 20 pi in radian. Okay. So they now said we should calculate what? We should calculate the angular speed. And we know that angular speed is equal to what? Speed is equal to distance. Normal speed is equal to distance over time. sorry, distance, normal speed. Normal speed is equal to distance over time. So angular speed should be what? Angular speed over what? Time. Angular displacement over time. What am I saying? Linear speed is equal to what? Displacement over time. Angular speed should be what? Angular displacement over time. So what do I have? Angular speed is equal to what? 40 pi over what? The time is equal to what? 10. So I'm having an angular speed is equal to what? 4 pi. And what did they give us at pi? 3.142. So my angular speed is what? 4 times 3.142. So my angular speed is equal to 18. How did I get? Okay. Okay, what they gave me is 30 oscillation, not 20 oscillation, please. Okay, so let's change this 20 oscillation. 20 oscillation. Aha. So this time this, then do the multiplication. So I'm having 4 times 3.142. So I'm having 12.568 in what? In rad per second. Okay, so that is that. Very, very simple to calculate. So don't forget that one oscillation is a complete circle. That's what you need to know. So the next question, they said define uniform acceleration. That one, all those definitions, that's not what I'm here for. So the second one said, the second example said, a body of mass 12 kg moves with a speed of 10 meters per second in a circular path of radius 5 meters. Calculate the magnitude. Calculate the magnitude of the force. Calculate the magnitude of the force acting on the body. Okay, solution. Now, don't forget that the force that is acting on the body is what? Is the centripetal force. Okay, the force that is acting in a circular path, okay, towards that radius, the inner one, is called the centripetal force, and is what? Mass times what? Centripetal acceleration, which is what? mv squared over what? Over r. So I'm having that the mass is what? 12 times 10 squared all over what? 5. So what do I have? 12 times 100 over this, so which is 12 times 20, which is equal to 240 Newton. 240 Newton. Very simple. Okay. So the next question. Okay, the next question said a body is rotating in a horizontal circle of radius 2.5 meters with an angular speed of 5 rad per second. Calculate the magnitude. Calculate the magnitude of the radial acceleration of the body. Okay, the radial acceleration of the body. So we need the angular acceleration. Okay, solution. Let us bring out what they gave us. They gave us the radius r, which is what? 2.5 meter. They gave us the omega, the w, which is what? 5 rad per sec. They now say we should calculate our A. Okay, don't forget that A is what? Velocity over what? Over time, but there is no time. There is no time. Okay, but there is something we can do. We can do something. Okay, do you know that normal velocity is equal to what? This angular velocity times r. Just attach r, I told you. But the angular acceleration is what? Normal acceleration times r. We know this one. Okay, so let us get our v. Let us get our v. In fact, the relationship between this and the alpha, don't forget, alpha is equal to what? I told you I just put square, w squared r. Even if you don't want to start doing all these things. So what do I have now? 5 squared times 2.5. So which is what? 25 times 2.5. And 25 times 2.5 will give you 62.05 meter per second. So that is that. Okay? So there is no big deal. Okay, we'll continue with the next example. So thank you very much for watching. Please subscribe.